Okay, here's a perfect example. Let's say that we wanted to go around a loop and find the mystery resistors. So we have all this stuff, we have a resistor here, and we have a resistor here. We're going to use both of Kirchhoff's rules to kind of figure this guy out. One thing I see immediately is this 2 amps flowing into a joint, and I see 1 amp coming out this direction. So my first thought is, hey, how much has got to be coming out this way? Well, 1 plus 1 is 2, so I know I've got to have 1 amp going through here. 1 amp this way, 1 amp this way. And then when you get back over here, you can kind of think of them as almost like rejoining, so 2 amps. So let's solve this using Kirchhoff. Now, it's very intimidating to see all these batteries around, but you'll see in a second it's really not that scary at all. I always have a habit, just to make mental organization here, is I always start with the biggest battery, okay? And I start just to the side of the negative. It's a habit of mine, okay? And I'm going to follow it around, because no matter what loop we go around, we're going to have to keep track of what we're doing. So we're going to start there, and I'm going to start moving up. So I'm moving up, boom. Okay, right away, I have jumped from negative to positive. So I've had positive, I have a 15 volt jump, okay, and I'm going to keep going around the circuit now. So 15 volts, bloop, 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 nothing, 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 nothing. Wires are basically treated as not having resistance. Okay, I get here. I think for all intents and purposes, I'm going to go for this outer loop, just because I think it's going to be easier. So I'm going nothing, 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 nothing. Now I get the battery. Okay, I'm at the positive, I'm going to the negative. So in my mind, I'm kind of thinking of myself as dropping down. So minus 10 volts. I've lost that. I know it's a battery, but you're going the other way. Okay, so keep going, boop, 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 boop. Okay, I don't really know what my resistance is here. So we know there's a voltage drop. I don't know what my resistance, but we can use here, V is equal to IR. The current is 1. The resistance is little r, so I'm just going to have to leave it like that for now. I'm going to keep going around my circle. Okay, coming all the way back over here. And I'm going to go up. So I'm still flowing in the direction of the current, so I'm going to keep subtracting this resistance, so minus. And when I get here, I can use V is equal to IR again, but be careful. It's not the same current as was over here. That guy was 1 amp. Now we're back in series with the battery, so it's 2 amps. So I could put 2 here, R, and the whole thing, we've come back to where I started, so the whole thing has got to equal to 0. Oops. And you can see it's actually not that bad now. So we got basic math here. We got 5 minus R minus 2R equals 0. 5 minus 3R equals 0. Okay, so we get R equals 5 divided by 3. So 1.67 ohms. Here's another good example of Kirchhoff's laws. So let's say we wanted to go, or Kirchhoff's rules. Let's say we wanted to go after this resistor here. Okay. So once again, we're going to start just to the side of the biggest battery. Okay. We're going to go in a loop. All right, so we're jumping up, or we're gaining voltage here. So we have 12 volts, okay, and we keep going. Now we're going down, okay, so we're losing. We're going to treat this as though it was a voltage drop. 6 volts, okay. We keep going, and I'm just going to keep following the path around here. So, boop, boop, boop. We're going with the current. So we can do minus, sorry, I keep switching my pen, minus the current, which they gave us, of 2, times the resistance, which is 0.2. Again, using V equals IR here. Okay, keep going. Now, we're going to keep going around the circuit. Getting back here, we don't know the resistance here, we just know the current. So, minus the current, which is 2 times R. Keep going. Okay. And minus 2 times 1.5. Oh my gosh, I'm going to run out of room. Okay. Okay, there we go. And so we get back to where we started. So minus, and I'm running out of room here. I can't stand that pen thing. 2 times 0.3. Okay, and all that pretty stuff has got to equal 0. And now, math. Okay, so 0 is equal to 12 minus 6 minus 0.4 minus 2R minus 3 minus 0.6. And now more math. And you get that. At this point, I'm feeling pretty good about myself because if things are working out this pretty, I probably did it right. I mean, maybe not. Hypothetically. Okay, so we got minus 2 is equal to negative 2R dividing and 1 ohm. Now you should feel amazing about yourself. My friend.